here we are solving maximum subarray problem. The problem statement says that we are given an integer array and we have to find the subarray with the largest sum and return largest sum. Okay, so let's see. The first example says that we have an array with these values and we have to return the maximum sum. So it says the sub array, this one 4, -1, 2 and 1 is the sub array which has the largest sum out of this, which is 6, and this is what we have to return. In the next one we just have a single value, and in that case that itself will be the sub array and we have to return the entire sum. In the next one we have these values, and then if you sum all these up, so this will be the maximum sub array and the maximum sum out of it would be 23. Let's see the constraints. So the constraints clearly specify that there will always be at least one value present in the array and the elements could be either positives or negatives. So the most straightforward approach that I can think of is we can apply two nested loops and we can traverse the array from the start to the end in the outer loop. In the inner loop we'll traverse from the iteration on which the current pointer is in on the above loop. So what do I mean by that is, if my outer loop is at this point, then my inner loop will go from this element towards the end of the array. Okay, so with this what we will be doing is we will be calculating the sum, and then from that sum we will be figuring out, okay, what is the maximum sum, and then we will be updating our maximum flag. So naturally this will bring us a solution, but then interviewer will not be happy and will be expecting a better optimal solution, and this is where the famous Kadane's algorithm comes into the picture. So as per the Kadane's algorithm, idea is we will be traversing the array just once, and on each traversal we'll check if this element and the sum before this element, if sum before than this element, is it greater, or this element is it greater. On each element, let's suppose if we are on this element, so we'll check if 4 is greater or the sum till here is it greater. So this is where our flag would be updated and we will be updating the references. Also stay tuned towards the end of this video because we will be also applying ES6 concepts on the Kadane's algorithm. Let me just expand this and let's start with our approach 1. In the approach 1, as discussed, we will be actually looping from the start towards the end of the array. Okay, and on each traversal we will be actually also looping from in the inner loop, which would be starting from the above traversed item, and we'll go towards the end and then we will say j++. Okay, we will be actually calculating our sum, which will be nums of j, and since we are calculating the sum we will have to declare it to as 0, and then here we will be also checking if my current sum is actually greater than my maximum. So in that case my maximum would be the sum, right? And here we will be also returning the maximum, and let me declare the maximum. So let me declare the maximum to be as -infinity because we have negative values as well. And let's run against the custom test cases. It passes. Let's submit this. So here if you see, we are getting time limit exceeded and our 204 test cases got passed out of 210, and this is expected because of the constraints. So order of n square is not a optimal solution. So in this case what we'll do is we'll move on to our next approach, which is Kadane's algorithm. So let's start. Okay, so let's start by declaring the variables as maximum to be -infinity and sum to be as 0. Now we will be traversing from the start of the array towards the array length. Under here we will be actually calculating our sum based on an operation of maximum, which would be my current sum plus the current element. So the idea over here is wherever I am standing in the array, the sum from the left, including that element, what is the sum? This sum compared with the current element, what is greater? The previous sum, is it greater, or the current element, is it greater? So with this we got the current sum. Okay, and now we'll update our maximum flag to be as math.max of this sum, the above sum, and the current maximum. So with this, we will be able to calculate the maximum sum, and at the last we will be actually returning this only. Okay, let's test against the custom input. Okay, this is nums of I, not num of I. Cool, it passes. And now we'll submit this. So we are able to solve this problem via Kadane's algorithm. Moving on to ES6 way. So there's nothing much left here as for ES6, but still let me show you. So as part of ES6, I think these are already using ES6. So what we can do is we can optimize this. Okay, and we have to change this to num and this also, and I think that's all. Execute this. Okay, perfect. So now moving on to the analysis. So let's start with the approach one. Time complexity. So for obvious reasons, it will be order of n square in the worst case, because here we have two loops. Okay, and space complexity, it will be just order of 1, order of constant. So space complexity, order of 1. Okay, so now moving on to the next approach, which is Kadane's algorithm. Here the time complexity is, yes, order of n. Let me just write it, order of n. Okay, because we are just traversing once. And what about the space complexity? So the space complexity will be order of 1 only. Why order of 1? If you recall the largest element problem, so there we were actually passing the entire array to compare with, and there the memory was actually be taken because of the array. But here we just have 2 arguments. We don't have the entire array. That's why order of constant space. Okay. And for the last one, I think it's similar to this because we just optimize the for loop. Got it? Order of n for this, order of 1 for these. Okay. That's all. Thank you.